On April 10th, 2025, the Climate Solutions Research Collective hosted the second day of the Climate+Water Research Symposium alongside our partners, the UBC Sustainability Hub. We acknowledge that the event was hosted on the traditional, ancestral, and unceded territories of the Musqueam people. The objective of the event was to connect researchers from across disciplines with a shared interest in water to discuss opportunities for climate solutions research. The UBC Climate Solutions Research Collective is a pan-university initiative designed to build connections across climate researchers, groups, and initiatives, and to encourage new collaborative research on climate change solutions. Our partner, the UBC Sustainability Hub, has a mission to inspire people to act upon the planet's most urgent challenges through UBC's academic and operational sustainability leadership. To realize this mission, the Sustainability Hub works to embed sustainability across all aspects of UBC's academic endeavors, focusing on student education and faculty support. It is focused on catalyzing change across UBC and beyond. The day's agenda included a plenary discussion on the topic of climate, water, and power, followed by an interactive workshop on exploring theater-based approaches to work alongside community partners in water research, and finally a roundtable discussion on connecting water and climate solutions-oriented research. This is a recording of the plenary discussion. The Sustainability Hub's Angélique Pilon welcomed everyone to the Center for Interactive Research on Sustainability. This building is a shared space in which UBC Sustainability is also housed. Angélique introduced the moderator for the plenary discussion, Nadia Kuntz. Nadia is an associate professor jointly appointed across the School of Public Policy and Global Affairs and the Norman B. Keevil Institute of Mining Engineering. The overarching goal of Nadia's research program is to quantify and mitigate the risks associated with the mining sector's use of water from diverse perspectives. She adopts an interdisciplinary toolkit ranging from the development of engineering and geospatial models to anticipate potential water-related risks, to qualitative field and interview research to identify the constraints and opportunities for transitioning the mining sector towards more sustainable water and waste management practices. Nadia holds several leadership roles at UBC, centered on convening interdisciplinary teams across UBC and with external partners, including Indigenous representatives and industry, to resolve complex challenges associated with the resources sector. This includes serving as the academic director for the Future Minerals Initiative and the Water Stewardship Theme Leader for the Bradshaw Research Initiative on Mining and Minerals. Nadia also serves as a Distinguished Fellow with the Peter P. Dillon Center for Business Ethics in the UBC Sauder School of Business, a faculty associate of the Institute for Resources, Environment, and Sustainability, and is a member of the Executive Committee for the Data Science Institute. Beyond UBC, Nadia has been an adjunct research fellow with the Sustainable Minerals Institute at UQ since 2018, and has served as an executive advisor to the Leveres Academy at UQ since 2024.
Angelique, and thank you everyone here in the room for joining us, and also those in Kelowna. Welcome to our panel this morning, which is focused on climate, water and power. I'm really thrilled we have such an impressive group here. We have three amazing speakers who you're going to hear from. We've got John Richardson, Werner Antweiler and Natasha Affolder. I'm going to introduce their bios as they come up to give their opening remarks in just a moment. But before we get started, I wanted to just introduce the topic of our panel and what it is we're going to focus on. So this title, Climate, Water and Power, is intended to bring together these experts that have knowledge in hydroelectricity, law, watershed management and business to explore the intersection of climate change, changes to water availability and power generation, as well as questions of transnational management of water resources. And when I first read the title, I thought power as in political power. So I know that that is something we will touch on, but also the idea of power in terms of electricity generation is going to be something that we'll be talking very much about today. Before I hand over to John, I did just want to acknowledge that we don't have an Indigenous voice on this panel. I think it's fantastic, Leslie, that you did have that yesterday in Kelowna. And I think just worth noting the significance that water often has to many Indigenous communities around the world, especially here in BC. It does have a lot of significance that I just wanted to make sure we respected that in the opening here to say so. So I don't want to spend too much time talking at you because I want to hear from our panelists. So I'd like to first introduce John Richardson, and we're going to have each of our panelists introduce their background, expertise, talking a little bit about their perspective on this topic today. So they'll each speak for around 6 to 8 minutes, and then we're going to have time for plenty of questions. I've got some pre-prepared questions, but I do encourage everyone here to already be thinking about what you'd like to ask these wonderful folk in front of you. So John Richardson is a Professor Emeritus and former department head in the Department of Forest and Conservation Sciences. He's a principal investigator of the Stream and Riparian Research Laboratory. The research program addresses questions related to the mechanisms that structure stream and riparian area communities and how various land use practices affect those systems. In natural communities, there are many processes affecting the rates of population growth or decrease, and John's laboratory has taken a largely experimental approach to determining what those feedback processes are, as well as how the rates are regulated and how multiple sets of interactions combine to affect population size and community structure. I'm sure we'll learn much from John in your remarks very shortly. I just wanted to also mention that he was previously the lead for the Future Water Cluster, which we had here at UBC, an interdisciplinary group focused on examining future states of water system design, management, policy and governance. And I was very grateful through that group, John, that I got to myself meet many wonderful collaborators here at UBC. So I personally thank you for that work that you did with the cluster. The interdisciplinary research that was undertaken by the cluster and its members intersected law, policy and governance, as well as the applied and biophysical sciences. He's also serves on several committees and panels, and we were just talking about how he's certainly keeping very busy in his retirement. So thank you so much, John, for making time to join us here today. And I'm going to switch spots with you so that everyone in Kelowna can see you.
Great, have to switch glasses. One sign of getting older too. Anyway, good morning. I'm glad to see that there are people here, and today is intended to be very interactive, create a dialogue. So anyway, welcome. And what I want to do is I'm going to make really just 3 points. Actually, maybe I can probably still read this. The light's not good for me. What I want to do is, well, first off, start off with a very shameless self-promotion and just point out that I have a textbook that was just recently published, and there's a whole chapter on climate change and water, but climate change really permeates the entire book because, of course, it intersects with almost everything that we do in terms of land uses, pollution, endangered species, et cetera. So climate change really is a big intersecting topic that really covers water globally. But I want to make 3 points today, and this is mostly just to get the conversation started for today. So the first point I want to get to is that humans don't do really, really well with variation. And, we do really well when we look at averages and we think, oh, yeah, we've got average snowpack. And you might have heard today on CBC, and we're still just below the average snowpack. But that's misleading because, of course, that's a 40-year some odd average. And if it could all melt before, the end of April. So variation. The second thing I'm going to talk about is water storage and hydroelectric power generation and some of the consequences of that for the climate systems. And the third thing I want to get to is the other environmental costs or environmental consequences of some of the things that we do with water. So the first point, next slide, is that in general, there's a lot of natural variation, and I think most of you know enough about climate science that the globe warming of the globe and the heating of the surface waters of the ocean has led to a lot more energy in our climate systems, which mean that we have much more intense systems. Even 10 years ago, people wouldn't have been talking about atmospheric rivers, but the energy from the oceans is leading to much more concentrated storms, and so we're seeing more hurricanes, earlier hurricanes, more intense rainfalls. But we're also seeing more pronounced high pressure systems that also lead to pronounced and extended droughts. And so we have that kind of problem going on. So we're going to see more and more variation. And that comes in a number of different ways. One is that we're going to see more problems with water supplies in the future. And that comes both in terms of oversupply as well as undersupply. And so we have to sort of grapple with the consequences of it. And this is just an example of a reservoir in Norway. But you can see, I think, the depletion of the water supply that was there at one point. And of course, you know, it just keeps going down through dry periods. And so that variation is something we're going to need to cope with. And it's not something that humans necessarily do a great job of. The other part of that is that we have things going in opposite directions. So we have, sorry, I'm having to keep track of this. So we generally have less water in the summertime. We have more people. We have 3 times as many people on the planet as we did 50 years ago, and yet we have no more water, of course. And so these things are kind of going in opposite directions. We have population growth, higher densities, more demand for water, same supply, and more variation in that supply. And so that's really a challenge for a lot of the things that we're dealing with. So we really need to worry about that. And in biology, we have this concept of density dependence. So you think about the amount of resource per consumer, and of course, those things are going in an opposite direction. If supply is going down because of evaporation, because of longer droughts, and of course, human demand is going up for all sorts of purposes, all the way from drinking, cooking, bathing, flushing, fighting fires, hydroelectric power generation, irrigation, mining, and other activities. Okay, so the second thing I want to talk about is the storage of water. So we have a lot of hydroelectric power dams. We have a lot of dams that are storing water for irrigation and drinking water supplies. Now, it's certainly, nobody's going to try to say that that hydroelectric power isn't a much greener alternative to any kind of fossil fuel, but it's not entirely green. So there are environmental consequences of storing water, one of which is that reservoirs store a huge amount of organic materials, and that comes flushing in the form of leaves and needles and branches and things deposited on the bottom of these reservoirs, where it often goes anaerobic. And when you have anaerobic metabolism, you end up with methane production and also nitrous oxide production. And those are 2 powerful greenhouse gases, both more than 40 times more powerful than CO2. So reservoirs are generally net generators of a greenhouse gas that's more potent than CO2, as well as that. Because you get these anaerobic conditions, you can get methylation of mercury. And elemental mercury occurs around the world, but when it gets into water and it's in an anaerobic condition, you get methylation of mercury, which gets up into the food web and into fish. And many of you have probably heard about problems with mercury pollution and contamination of fishes, and especially in indigenous communities which rely on fish. They often have limits to how many they can eat. So that's another issue. The other thing is when you stop water from flowing down a natural channel, the water heats up at the surface, and with the hotter water at the surface and of course hotter temperatures, we have higher evaporation, and many reservoirs actually lose close to 15% of the water that would have been in the native flows if the river had continued to persist. So we lose water as well. So there are environmental consequences of creating these dams. Next slide. Sorry, I should have gone to this, but one of the things about reservoirs is that they're also a very big environmental challenge for biodiversity. So of most of the big dams in the world, more than 50% have no fish passage. This is the Glen Canyon Dam in the Colorado River. Was once one of the biggest dams in the world. It's now dwarfed by about another 15 or so dams that are at least twice as high. But one of the things with reservoirs is, of course, if there's no fish passage, then all of the habitat that had been there previously is gone, and downstream of it is not any better. So in the reservoir itself, of course, it's now become kind of a lake. So it's not habitat for most of the species that could have got there, if they could have got there. We build fish passageways. Those aren't necessarily the best solution, but they're a solution. But the other thing that happens here is the water at the surface gets heated because it's exposed to the direct rate of shortwave radiation, and the water at the bottom is cold. And so depending on where the water is released from, the downstream environment may get hot or cold water, depending on what's coming out. But the other thing is that the flows are controlled, and they're controlled primarily for human purposes. And so that means that anything that the fish or any other species downstream might have needed in terms of flushing flows to wash away fine sediments, they don't happen usually. So there's a problem with that. The other thing is that I mentioned the organic materials coming into these systems and stored within the reservoir. So that means that that's not being supplied to downstream environments where that would have been a major carbon source for a lot of the organisms. So again, we're changing the food supplies to a lot of the aquatic ecosystems downstream. We're changing their temperatures, we're changing their flow patterns. The other thing that happens is it stores sediment too. And so all the sediments that do come into the reservoir stay there, which means that things that need finer sediments or gravels downstream aren't getting those for spawning. And there's some really interesting stories of how people have tried to deal with that. So next slide. So there are environmental consequences of doing this kind of things. And so we do need to think about how do we provide for our natural ecosystems as well. So there are things like environmental flows, and we'll maybe get into discussions about some of those later on. But we have to think about how do we balance off the natural needs of our aquatic ecosystems and the nearby ecosystems that rely on fresh water, the riparian areas. So how do we deal with that, balancing human needs? And that's a real challenge for a lot of purposes. When we go into drought periods in BC, you know, the last thing I think most people think about is fish or anything else. You know, it's more about green lawns, isn't it? Or at least for some people. So I think we need to think about that challenge of how do we balance these things. Just the last slide. This map is now about 15 years out of date, but the main point of it is just really to show that where there are human water issues shown in the red, and more warmer colors pretty much overlap with where there are biodiversity problems. And that's probably not at all surprising. And this is where the human nature conflict kind of comes into play. And I just wanted to end by pointing out that freshwater ecosystems are actually having a decline in diversity and abundance 6 to 10 times higher than the rates found in terrestrial or marine systems, depending on the calculations that are done. So it does mean that we have to think carefully about the balance between our natural heritage in terms of ecosystems as well as human use of water. And so that'll be hopefully part of the discussion today. And I'll end there and let our next speaker come up.
Thank you so much for that, John. That was a wonderful overview, and I certainly learned a lot myself. I think it highlights that there's no free lunch when we think about our energy use and consumption, and those impacts you mentioned from hydropower are very significant. So thank you for all of that wonderful introduction. I'm going to pass over now to Associate Professor Werner Antweiler within the Sauder School of Business. His research interests include international trade and business, environmental economics and management, energy and electricity economics, applied econometrics and panel data, applied empirical finance and prediction markets. He's a frequent commentator on broadcast media about a wide range of public policy. His work includes environmental and energy topics, and in particular renewable energy in electricity systems and the electrification of mobility. He's a chair of Sauder's Strategy and Business Economics Division, as well as the chair in International Trade Policy. He's also a steering committee member of the Climate Solutions Research Collective. And just in conversation before we started today, Werner was just mentioning how many calls and interviews he's been doing recently on trade policy at the moment and tariffs. So I'm sure that will come up in our conversation today as well. He is your go-to person at present for those questions. So without further ado, I'll pass over now to Werner. Thank you.
Well, this province runs on hydropower. The lights are on, and when they go out, we all know like we're in trouble. And climate change actually not only affects generation and hydro dams, but it's also affecting distribution. For example, when we have windstorms or fires or floods, it brings down our power lines, and it's another vulnerability that individuals and communities can experience. But it's something that is also increasingly a worrisome future of climate change effects. Now, next slide. Let me actually start in the United States, because some of the effects of climate change on water hydro systems is much more apparent in the US, because they have a lot more exposure to it than we here in BC as of now. That may change. But if you look at this image from Lake Powell, just over a few years, between 2017 and 2021, you can see from the satellite pictures that the lake has shrunk. You can see that when you get to the dam by seeing the bathtub rings in the lake. So clearly water levels are actually decreasing there, and in fact power output is going down too. You see the water level there in that chart as well going down here over time. Now, the stress comes from a number of sources. It's not just the supply of water, but it's also the way the water is being used. And with population growth in some regions, there's also more water use. So the stress on reservoirs is not just from the hydropower source. Next slide. So if you actually look at, actually, this is a typo, it's 2023 there in the corner, not 2033. It's, you can see actually some of the power output in the northwest is actually slightly declining. So it's not as high as it used to be. It's still a small decrease, but it's even something that's noticeable here in the Pacific Northwest. Now, here in BC, that is something that is much more readily observable over the last year. Next slide. I'm a trade economist, so I look at a lot of international trade, and in particular, trade in electricity. British Columbia actually trades with its southern neighbors, Washington State, Oregon, and California. And in past years, we tended to be exporters of electricity in terms of volume. Now, that has actually changed over the course of last year. For the first time, we were a major importer of electricity. At some point, when we see that going there to 1,800 gigawatt hours in a month, that was essentially roughly a quarter of our electricity supply that was coming from the United States in the summer, where our electricity needs are relatively low. That doesn't mean we're in a dire crisis yet, because in fact, we are also exporting some electricity. And even though it looks like pretty small, the blue and purple bars on the top, and that is actually of high value. The prices for exports are much higher than the price for import. We get cheap solar power from California in the summer and during the night, and then we sell it at a premium in the winter. So in fact, British Columbia is acting like a giant battery for the Pacific region. So that we, in fact, end up not with a negative impact on our hydro bills because of that trading opportunity. The folks working for PowerX, they're doing a great job actually trying to maximize the value for British Columbians. So don't be worried about your electricity bill quite yet, but the imports are quite large. We have been utilizing the power lines in this one direction a lot more than in the past. And that has been prompted by drought conditions that have been more pronounced last year than this year, it appears. So when we are looking at these conditions, we are looking at water levels and we're looking at snowpack levels. The snowpack levels were actually quite low last year. This year, for this winter, we're kind of okay. But again, it's not where climate is on a linear trajectory. There are phases when we go through El Nino and La Nina cycles, and we have sometimes more pronounced periods of drought conditions and sometimes less. So the long term is still something that BC Hydro worries a lot about. And in fact, in 2012, they commissioned a study on the effects of climate change on hydro resources. Next slide. So one of the numbers I look at very carefully is our water levels in the reservoirs. We have two major reservoirs in BC. One is near the Shrum Power Station. That is, in fact, the Williston Lake Reservoir. It's the largest one. And there you can see the water levels over a couple of years. Last year, you can see that orange line actually not being quite so bad in March, April. We had inflows during that time. And then it's actually much lower than normal in the months during the summer and early fall. So that is a typical sign of what's happening. We have larger inflows early on. So we get the snow melt, that's less and earlier. And then in the summer, we're actually not running the reservoirs quite at the same level. And so in that sense, there's a worrisome future if that actually repeats itself. This year, you can see we're not starting well. That last line for 2025, it stops in April. You see we're kind of at a lower level than last year. So this is a question mark as to where we're going. Now, Next slide. The other big reservoir, this is the Mika Dam and on the Columbia River. Now, there are several other dams further downstream, the Revelstoke Dam that you may know about, and a few more all the way to the United States. Now, this year actually looks roughly good in that particular case. So you see the line for 2025 being above where we were in previous years. So what you see is heterogeneity too. It's not just a pattern that is the same everywhere. So we have very important regional patterns too. In some way, we hope it sort of balances out in the end, but it's importantly showing that we need diversification in our resources. So if you're exposed to only one watershed, we would actually suffer these consequences of climate change much more pronounced than if we have a regional diversification and the opportunity to trade. Next slide. The other big issue in terms of climate change is the snowpack. So we have actually two types of storage. The one in the reservoir, and then the snowpack that's kind of working as secondary storage. And we're getting less snow and more rain. That is even more pronounced in California, where that effect is much more noticeable. But here in BC, that may be a trend too long term. We're not getting less precipitation overall, according to some of the studies from the international researchers on climate change that do the global modeling. But it changes in the way it's coming down. It's coming down more as rain, less as snow. We get less snowpack and less late spring runoff that replenishes our reservoirs. So that is one of the effects that we're quite worried about, that free secondary storage that was an extra reservoir it may not work in the same way in the future as it is today. And one more slide. Okay, and this is a picture at the global scale. Now, what we're seeing here in BC is different from what we're seeing elsewhere in the world. So it's really important to understand that the threat to hydropower systems is quite different in different places. In some cases, it's drought conditions, but in other places, you can see there are issues about earlier snowmelt, extreme precipitation, and even floods. So the problems can also be a much more concentrated rainfall that's overwhelming systems where suddenly you have all the water coming in, you can't store it quickly enough, it's runoff, you're not capturing it. So how we actually manage these water resources going forward may also require some rethinking of how we manage reservoirs and make sure that we mitigate these threats that are coming from different directions and different places. So if you look at the map here, you see in all the regions that rely on hydropower, the problems are somewhat nuanced. It depends to some degree on the latitude, to some degree on the elevation, and of course, in some cases, it's very much an issue of just dry conditions. Global temperatures are rising. That means, on average, we're going to get more rain than snow. I think that's easy to see. But we're also getting the shift in how rainfall is experienced over time. Is it more concentrated than the past? And that means the problems are numerous. How we manage them is one of the key challenges. And last but not least, there's also the issue that our water doesn't stop at borders. Water flows across the borders, and we have to work with our neighbors who are not always cooperative on all the things that we need cooperation on. We have been in negotiations about the Columbia River Treaty that was ready to be signed last year, and then it didn't happen. The administration in the United States obviously changed, and some of the changes that we were hoping to see, modernizing the treaty from 1964, essentially, after 50 years, 60 years, pardon me, would have been much needed. But it's now on hold, pending further negotiations, and it's a big question mark what will happen with the renegotiated Columbia River Treaty. And with that, let me stop here and turn it back to Natasha. Thank you.
Tremendous. Thank you so much, Werner. That was fantastic. And I think you could come and give a talk to my water and mining students with all you know about water systems. That was, I learned a lot about hydro and water. So thank you. And perfect segue to our next speaker, Natasha Affolder. So yeah, just I think in terms of thinking about how we need to work with our neighbours and how water flows across borders, we're very lucky to have Natasha with us, who's a professor and former Associate Dean of Research and International at the Allard School of Law. She's a leading scholar in transnational environmental law, whose research explores some of the most challenging and complex issues of our time. Her recent scholarship has sought to reveal and challenge the marginalisation of environmental law in legal practice and scholarship, and to creatively expand the methods for studying environmental law and its global movements. She's the recipient of numerous awards, including most recently the 2019 Richard McCrory Prize for the best article published in the Journal of Environmental Law. She's a sought-after and frequent panellist, keynote speaker and commentator. Professor Affolder has put her scholarly expertise to work as an advisor to Indigenous communities, environment and development NGOs and governments across multiple continents. She's a member of both the Centre for Feminist Legal Studies as well as the Centre for Law and the Environment at UBC. So thank you so much for coming to give us some of your wisdom today.
Thank you, Nadia. And thank you, organizers. But where I really want to focus my thanks is on you. It's been quite a week. Not only finishing classes, thinking of exams, preparing for exams and marking exams and papers, but also dealing with some onslaughts and attacks on institutions that we hold dear across the border. Seeing people worried and uncertain with this crazy roller coaster of the stock market in recent days and even this morning, for those of you who haven't looked at your apps. We've also been bruised and battered with the uncertainty of things like what will happen to the core treaties that we've negotiated around climate change. The Columbia River Treaty was just cited, and the list kind of goes on. And yet, you are here. And I think when I often get asked where I go to for hope, it's about people. It's about the people who show up day after day, even though there's reasons not to stay in bed, to do other things, to luxuriate in the awfulness of the news and feel uncertain about ourselves. And so I knew I was following two superstars, and not surprisingly, John gave us a really full and complex picture of the natural ecosystems and the physical infrastructures that we have to have front of view. And Werner complicated that with a view of the political, the economic, the global, of power in many guises that, as he said, brings us the lights on in this room. And so in thinking about what could I possibly add to that, I wanted to spend a minute thinking about the human. And in law, we're pretty conscious that laws are made by humans. They are made with an attempt to alter human behavior and to structure human relationships, particularly around conflict. And so I gave us these faceless and admittedly melting humans because I want you to populate their faces. I want to think for a moment why you are in this room. And my guess is that the reason you're here traces to people whose faces you know, people who taught you what was important, people who mentored you, people who taught you, people who inspired you. And so we all have these human faces that give us a reason to say, sure, the US withdrew from the Paris Agreement. The Columbia River Treaty negotiations are on pause. Even if we negotiate new international agreements on water, they might not be respected. But yet we come back. And I think thinking about that resilience that we have inside of ourselves lets us have a way of dealing with these other questions of, but what if and what about and haven't you forgotten? And so that's where I wanted to start us off. I have two comments that I wanted to make that I hope will help our conversations that sort of unfold the rest of the day about interdisciplinary work and the real pleasure of talking to people who have very little idea what you're talking about. And I think for me, and we can have the next slide, a particular joy of talking to people in really distant disciplines from our own is realizing how selective our view is. So we may make ourselves, absolute blue in the face focusing on one issue. And then we talk to someone else and they don't really see why that would feature at all. It could be devastating, but it's usually kind of refreshing because, the weight comes off our shoulders. We don't have to get everything right. And the reason I say that is because as someone who works on climate law, people have often a very restricted view of what bits are relevant. And so the bits of climate law that make the news are the solutions, the innovations, the new, often youth-led climate litigation that makes us think, there's hope because I read that there's this case. And in this case, this happened and that happened. And it's one case in the whole world, but it's that visible 1% that gets people excited. So we had a case come out of the United Kingdom Supreme Court recently called Finch, where the judges said, this makes sense, this stuff. There is enough global consensus in science. When we require an environmental impact assessment, we are going of a new fossil fuel structure. We are going to say that what needs to be measured is not the significance on the ground of the footprint of this project. We're going to say we have to understand the environmental impact of all the downstream significance of burning that fossil fuel over time in different countries. That's what thinking about environmental impact assessment means. And so these little sort of bright lights are exciting. They certainly attract, lots of media attention and lots of scholarly writing. And students demand that we have courses, just about climate litigation. But yet, there is this other 99%. There are all the systems, some of which Werner alluded to in his talk, that set up commercial law concepts, property rights, protection of contracts. There's a 99% of law we don't call climate law. And so I think you can probably think of analogies in your own fields. Things that the media and others get excited about that are sort of packaged as solutions. And then all the underlying norms, assumptions, doctrines, concepts that might effectively undermine the little bit of good in the 1%. So I think as someone who spent years representing clients in private practice and now has the luxury of being in an academic world, I'm really alert to the fact that we get to choose our own research foci and our own agendas. And I'd urge us in thinking about how we approach the solutions to problems of water, climate, and power, that we remember the 99% sometimes. The last thing I want to spend a moment thinking about, and this again is about, I think, the transition that many of us have, or the multiple hats we wear as academics, as advisors, as consultants, is to spend a moment thinking about the direct and indirect sources of pressure on us to produce research that's not just relevant, but that is now scalable. Ideas that we can transfer, spread, disseminate, multiply, amplify, scale up. And I'm guessing more than a few of us have had the experience of coming up with a good idea, or maybe doing something in the depth required of a doctoral thesis. And immediately people jump on us and want to know how that can be reproduced elsewhere, how it can be scaled up, how our tiny little thing we learned can be significant over time and over space. And I know this creeps in to so many conversations about solutions and the sort of figuring things out that we need to do. So I wanted just to throw that out there as something that we might think about. Can we just luxuriate sometimes in one good idea, or imagining Werner's map of the complexity of hydropower challenges across the globe? Can we acknowledge sometimes that things are messy and complex, and we've done something in just putting that out there and admitting it out loud? So I look forward to your questions.
Thank you very much, Natasha. That was a wonderful introduction. And I just want to thank you for giving us hope. And I think you're absolutely right. You know, showing up and being here, because we're all of us, I'm sure, in one way or another, passionate about changing the world for the better somehow. And I think in these times, we do need to have that hope and take time to acknowledge that. I have about 1,000 questions, but we have only a short time left. So I want to make sure that we get questions from the audience. So I'm going to see, does anybody have any burning questions for our panelists that they'd like to ask? If not, I can kick it off with one, because, and this is probably linking it back to my own research area. I was very interested in some of the introductory comments we had around the significant impacts that hydropower can have, and also the challenges with there being enough hydropower. And I guess in my world, thinking about the mining sector, we have right now a big push for expanding mining. The province is trying to speed up expansion of new projects and increase approvals in order to feed minerals for the energy transition, as well as to buffer the economic impact that we're now facing in the tariff war. So my question is around, I guess, how do we grapple with, will we have enough hydropower for all of these different needs that we're demanding, and what are the environmental trade-offs that come with that? I guess I'm curious if you can reflect a little bit on that, and in the meantime, I'll keep my eye for hands because I haven't seen any yet. There's one. Perfect. Anyone want to jump in on that, Werner?
Well, I hear this question a lot. Will we have enough power to do all the things we want to do with the energy transition, electrification of mobility? Then there are demands from the mining sector, expansions of port facilities, and the biggie is LNG. Because if LNG happens on a large scale, electrified, we're going to need terawatt hours that we don't have yet. Now, we have just brought online this last year the Site C Dam, which is producing up to 5 terawatt hours a year. And BC Hydro had a call for power that was very successful, that was oversubscribed, and they're will be developing wind power for another 5 terawatt hours. So this is actually probably the direction the province will go to, because we're running out of places to build dams. And with all the impact, we may not be sure we want to build more dams, even if we could. Now, the opportunities that we have are in the wind power, first onshore, and eventually maybe also offshore. So there's significant potential in BC to develop new electric resources in different places. It will take time, and hopefully it will be done sustainably and not for the wrong reason. So I'm a bit of a critic on LNG. I can talk a little bit more about that, but it's one of the issues where we need more power if we want to manage the electrification of mobility, now have more EVs on our roads and fewer fossil fuel vehicles.
Yeah, I think one of the consequences of electrification is just increasing demand and limited supplies. And we are running out of places to put dams. And of course, there are environmental consequences. The other kinds of green energy sources, solar, wind, really suffer from the lack of ability to store it. And I know that there's been an enormous international effort trying to figure out how do we store energy. You can't make batteries big enough. People are talking about molten salt in the earth and trying to turn turbines from that and things. Because a lot of the alternatives, solar and wind, are kind of unreliable. And in some climates, of course, here, winter, you just wouldn't expect very much in terms of solar. So we have storage capacity issues for alternatives. But we do also have this enormous grid. But then you have a huge amount of infrastructure trying to keep that grid connected. And of course, that has its own consequences of requiring a lot of metals and environmental consequences of mining that goes along with that. So there are a lot of things that have to be balanced. I don't think there's any simple solution to most of those kind of things. I think it's a very complex issue. If it was that much simpler, I think we'd see places solving it. But we look at California just as an example, the water wars in California. It's really clear that it's not a simple solution, and that there's lots of competing demands, and we need bright minds to kind of figure out our way through it. But we do need to be looking at a changing world, not only in terms of climate change, but just in terms of population growth and human demands on the environment. And so all of those things are kind of going in opposite directions. As I said earlier, that populations continue to increase. Some of you, or maybe a few of you, were old enough to remember the 70s and the zero population growth movement. People anticipated this 50, 60 years ago, and that population growth would be an issue. And of course, it is having increased from about 2.5 billion to over 8 billion in the last 50 years. So, I think pretty clear that's one of the sources of the issue we deal with. But that's not going to change, and not going to change anytime fast. But it is one of the consequences of more consumers needing more power. And of course, now we're trying to get that power from greener sources.
Yeah, I might just jump in and have us think for a minute about the urgency. And I think that your comments reflected on this. And we get this message that we need new sources of power on board very quickly. And I think yesterday in Calgary, there was an announcement made by Mark Carney that there would be a new Office of Major Projects that would work to very quickly bring on conventional fossil fuel projects and clean energy projects, and do it by cutting red tape, reducing the amount of time, project reviews. We would get all this quickly. And I think that we didn't hear these words, sustainability and thoroughness and, excellence of environmental review. And so I think that those of us who feel like we're slow anyway, working in academic contexts where we often have the luxury of being thoughtful, have to sometimes think, well, what are we giving up to gain speed?
Thank you. We have a question at the front here.
Yeah, I was going to ask about LNG, but maybe I'll expand upon that. And it's another example, and the one I often use before that is sort of using biomass that we send on diesel-powered ships to Europe, so that Scandinavia can say we have green energy. And if we think about using hydropower for LNG that we're actually sending to Asia, these are examples of sort of, I would say rather bizarre things that are a function of, the market. And I guess I'm just wondering, is there another way that we can do things more rationally? Maybe this is for Werner. Concepts. How do we get out of these sort of, I think, really bizarre systems?
Yeah, one of the challenges we face is that when we trade across borders, we're not dealing with the same jurisdictional authority. And when we have climate policies here in Canada, we may not have them somewhere else. And so there's, for businesses, an opportunity to now buy in places where they can make a profit. And the problems that we're ending up with is that we're not looking at the externalities that are generated along the way. The right solution is, from a global perspective, is to have a real proper life cycle analysis of all the emissions that are generated along the way from all the sources in all the places. Now, they're not priced properly. So the biggest failure we have, as economists, I would call it a market failure, is that pollution isn't priced. And to the extent that we are lacking the instruments to balance this, now we're running short on these outcomes. The European Union has now introduced something called the carbon border adjustment mechanism. So when they import goods, energy goods from foreign countries, the producers that are bringing this in will have to pay an adjustment that is essentially bring it to the same level of carbon pricing as in the European Union. So one way to deal with these cross-border issues is to be more mindful about that we're treating the foreign goods that are not subject to a carbon policy at the same level that we have here in Canada, at least still for the large emitters. And so when we're looking at the policy domain, we kind of have to level the playing field to make sure that we're not having a race to the bottom, but a race to the top. It's not a perfect solution, but it gets us closer. LNG is in part problematic because it's heralded as a transition fuel, not really taking into full account that there are upstream emissions, especially for methane, that we learn a lot more about, and they are much higher than we thought even 10 years ago. And so some of the calculations don't really work out in the same way that people were thinking 10 years ago. There's much to be done in that way. Yeah, carbon tariffs. So the carbon border adjustment mechanism is another term for carbon tariff. Yeah.
So we have only 5 minutes left. So I think the lady in the second row had her hand up. So what I'm going to do is ask you to, or maybe you can ask your question. You look like you really want to ask your question. So you can ask your question as well. And then I'll just invite the panel to give some closing remarks. So we'll answer it that way. So please go ahead.
Sure. With the issues of our southern border, and also with a lot of talk about barriers, interprovincial barriers to trade. I know our north-south grid is better connected than our east-west grid. How critical a piece is that to this whole situation? And Werner, and maybe you could comment on any legal sort of limits to that.
Yeah, so the legal aspect is really important because we're dealing with two jurisdictions, like say Alberta and BC, and we have different power systems. One that's a monopoly system in BC, and then we have a very competitive market system in Alberta. And the Albertans don't really allow the full use of the existing power line because a significant portion is set aside for essentially market maintenance when they need it as a backup. So we're not really exporting clean electricity from BC to Alberta at the level that we could. So how to bring down that barrier? And that's an interesting legal question because it's a jurisdictional issue. The energy issues are all under provincial jurisdiction, and the federal government only gets in on any transboundary approvals of big projects like power lines.
Yeah, to jump in, I would say that, we have so many examples where legal barriers and borders make us do things that don't make sense. For example, if we look to the United States, there's, massive market for Quebec and Ontario's clean energy in New York City, but Vermont, Maine, the border states can stop those pipelines being built and that energy from flowing. So you'd say, it's not left to the market. It's not left to clean energy where there's a demand and supply, but we throw in political boundaries and borders the way we have in those situations, and they're pretty impermeable.
So we'll let you ask one final question and then invite the panelists to just give some final thoughts. I've been told we can have an extra 5 minutes, so we've got a little bit of breathing room, but yes, please go ahead.
My name is Bodhi. I'm a student that just finished my BA in Environment and Sustainability. I'm doing a master's in management. And I'm curious, in a time where US trade policy is failing and there's a lot of geopolitical conflict, like the role of Canadian leadership, not only stepping up in terms of climate litigation, but also on the global stage in terms of funding for like Canadian-led climate solutions and what we might see over the next couple of years through this administration. That's mostly for you, Natasha.
Hey, I don't have particular expertise in seeing the future. I certainly wouldn't have guessed the present. So I would say there's lots of opportunities, but I'm usually reluctant to say it's someone else's job and it's that person there who's elected into office. I see really good things happening in such a plurality of places. And so I look to all those places. I look to the sort of work that Nadia's doing in bringing the mining companies on board. I look to the scientists. I look to Indigenous communities who are showing incredible climate leadership. I look to, people I talk to on the bus. So I would say, I don't have this salve that says, well, we are going to see federal politics change and transform. And it's probably why I'm here doing what I do and why I'm not in the political world. So I would say, let's ask those questions that you're asking of everybody and not just of political leaders. And that could be my closing remark.
We might just have closing remarks then from Werner and John. And if you want to share some reflections on these questions of leadership and politics, would be great.
To look into the future, like we all would like to have that perspective. What's the world going to be like in 50 years from now? Are we going to have addressed the challenges of climate change? And I worry that policy alone isn't going to accomplish this. I have very little faith in the politicians really living up to long-term agendas. They're only living from one election to the next or whatever their agendas might be. And ultimately, I think much of the solution will come from innovation. If renewable energy is cheaper than the fossil fuel, if the electric car is cheaper than the fossil fuel car, these are the kind of things that will help drive it globally, even in places where there isn't a policy. That said, we do need leadership in those places that promote innovation and pioneer solutions. And here Canada has to play a big role, I think, because we can. We have the ability to develop solutions and we can test them, we can deploy them, we can scale them up. So the early adopters do play a big role in bootstrapping the process that will then hopefully spill over globally, because once we have these solutions and they're cheaper than the fossil fuel solutions, we can get there. But we won't get there without some countries really initiating the process and paying upfront. Some countries like Norway have been doing this very aggressively because they can, they have the resources. Like Canada is another rich country. We can do a lot of things and we should. And that means we're also paying forward to the future generations and to the countries that can't afford those solutions yet.
Yeah, I think this is one of the major challenges of our lifetimes, really. Water is critical to everything and that we do as humans and for the rest of life on the planet. And it's a non-stationary system, and most of you know that when we deal with non-stationary systems, it's really difficult to kind of get an equilibrium solution. And so we're dealing with changes of climate, we're changing human population sizes, we're changing how we use water. All of those things are going in different directions. They're non-linear. They don't add up easily. And it's a big challenge for all of us. And I think one of the key things that I would take away from messages this morning, and I would say to you, is that we really need to think of water in an interdisciplinary way, that there is no single silo that's going to solve this, that we really need to be talking to each other. And one of the things that, again, this forum is intended for is to really think about how do we cross disciplinary boundaries and really think about all the different dimensions of water and how we manage those for a more sustainable planet.
Thank you very much, John. And I think that's a perfect segue into the next part of the program that we have this morning, to also be encouraging us to interact a lot more with one another as we think about solutions. And thank you also, Natasha, for highlighting the importance that each of us in this room play in solutions and thinking forwards towards what future it is we wish for. And we certainly all in our work and lives have a role to play as consumers, as academics, as future leaders in all other directions, depending on where the folk in the room end up. So yeah, I really want to thank everyone on the panel, all three of you, John, Werner and Natasha, for making time to, out of your very, very busy schedules, I know that's true of each one of you, to be with us today, and to the organisers as well. And most importantly, to those in the room, those that have shown up, both here in Vancouver and also in Kelowna. So thanks so much for your time.